In this video, I will demonstrate how to machine the 0.375-inch step using Open Contour Toolpath. First, we should make sure we have the correct toolbars loaded. To check this, choose Settings, Toolbar States. From here, select the 2D toolpaths, and you should see the 2D toolpaths icon appear on the left side of the screen. Choose Load, and press the OK button. The toolpaths will appear on the left side of your screen. Within Mastercam, there are three ways to go about selecting toolpaths. The first way is to go up to the menu and select Toolpaths. The next way is to right-click in the Operations Manager. The third way is selecting any of the options on the left. I will now cover the chaining process, selecting a tool, as well as important parameters found within the dialog boxes. To start, we will machine the two steps using Open Contour. A contour toolpath removes material along a path defined by a chain of curves. Contour toolpaths only follow a chain. They do not clean out an enclosed area. From here, select Toolpaths, Contour. We will then be prompted for a new NC name. For this example, we can keep the default name. Choose the OK button. The chaining dialog box will appear. These settings have been covered in a previous video, so you should understand the settings found here. If not, please go back and review the exercise. We can leave the default settings as shown and pick the following line. Make sure that the chain is going in the clockwise direction. If the chain is going in the wrong direction, use the reverse button to correct the chaining direction. Chaining is important because it determines the direction the end mill will move across your part. As well, it determines whether or not you are climb milling or conventional milling. You can now select the OK button to exit the chaining dialog box. Now we will see the Contour Toolpath dialog box appear. From here, we could select a different toolpath if we wanted to. Also, we can rechain the geometry. To the left side of this page is a tree view list. Here we can select different settings and change the parameters to create our toolpath. Below the tree view list is a Quick View Settings dialog box. Here you can quickly glance at the tool-specific parameters. From the tree view list, now choose Tool. From here, click on Select Library Tool and disable the filter. Now click on Diameter to organize the tools. From here, select the 1-inch flat end mill from the tool list. Select the OK button once complete. Your tool will appear as shown. Note that the tool number is automatically set to 1, based on the option that we selected earlier, Assign Tool Number Sequentially. Now, enter in the comment, Machine the 0.375-inch step. In the tool page, we can change the tool number, the length or diameter offset, the head number, the tool diameter, and the corner radius if the tool has one. We can also set the spindle direction to clockwise or counterclockwise. Feed rate sets the rate at which the tool moves through the material. Spindle speed determines how fast the spindle revolves per minute. Feed per tooth sets the amount of material removed per flute. Surface feet per minute displays how many feet per minute the till will cover. Plunge rate sets the rate the tool will plunge into the material, whereas retract is how fast the tool retracts out of the material. Select the cut parameters. On this page, we can set out compensation type. This determines the tool compensation, adjusting the toolpath to allow for the cutting tool's radius. There are 5 different types of compensation. Computer automatically calculates the compensated tool's positions based on the dimensions in Mastercam. Control uses the machine's control to calculate the positions instead of Mastercam. Using this option will output G41 or G42 in your NC code. Where has Mastercam calculate the compensated tool positions but also outputs a G41 or G42 code. This lets the operator adjust for tool wear at the machine. Using this option, you would input the difference between the selected tool size and the reground tool size at the control as a negative number. Reverse wear works just like wear, except the wear adjustments are input as a positive number. Finally, off. Mastercam will not compensate for adjusting the tool's position. The center of the tool will go down the selected chained entities. For all of our tutorials in Mill Level 1, we will be using computer. Now, set the compensation direction to right. This determines which side of the chain the tool is on based on the chaining direction. Roll cutter around corners set to sharp inserts arc moves around the corners in the toolpath. The radius of the arc moves is equal to the radius of the tool. Ensure that roll cutter around corners is set to sharp. Ensure that infinite look ahead is also enabled. Infinite look ahead prevents the toolpath from crossing itself. Below is stock to leave on walls and floors. Stock to leave on walls and floors leaves a specified amount of material on the part to come back with a finished pass. Contour type sets the type of contour toolpath. There are 7 different contour types based on the selected geometry. These will be covered in future tutorials. Now select Lead In, Lead Out. Lead In, Lead Out dictates how the tool will enter or exit the part. Disable both entry move and exit move. Now, enable Adjust Start of Contour and input a length of 60. Enable Extend. This will extend the start of the contour. Now select the copy button to extend the end of the contour. This will also extend the tool 0.6 inches past the end of the contour. From here, select the linking parameters. Enable clearance and ensure an absolute amount is set to 2. Also, ensure retract is enabled with an absolute amount of 0.25. Now change the feed plane to 0.125. Finally, change the depth to an absolute amount of -0.375 and choose the OK button to generate the toolpath. Next, I will show you how to check your parts using Backplot and Verify. To backplot the current operation, click the Select All Operations icon in the Operations Manager. Ensure that the following operation has a green check mark next to it. Now choose the Backplot icon. Backplotting shows the path the tools take to cut the part. This display lets you spot errors in the program before you machine the part. As you backplot toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. From here, select the Backplot tab and enable the following settings as shown. All Operations, Follow, and Leads. You can now choose the Home tab and make sure you have the following settings enabled: Tool, Fixtures, and Workpiece. Finally, select the Play Simulation button to run the backplot. Your toolpath will appear as shown. Now we will simulate the toolpath and verify. From the Mastercam Backplot Home, select the Verify button as shown. Verify mode shows the path the tools take to cut the part with material removal. This display lets you spot errors in the program before you machine the part. As you verify toolpaths, Mastercam displays additional information such as the X, Y, and Z coordinates, the path length, the minimum and maximum coordinates, and the cycle time. It also shows any collisions between the workpiece and the tool. Ensure that the following are enabled: Tool, Stock, Fixtures, and Workpiece. Now select the Play button. To view the whole part, select Isometric View and Fit Screen. Your part will appear as shown. You can now exit Verify. In more detail, I will now explain the other icons located in the Operations Manager. Starting with the top row of icons, select All Operations. This will pick all operations you have created. Beside that, we have the option to select all dirty operations. A dirty operation is any operation that has been modified and needs to be regenerated. To the right is Regenerate all selected operations. Then we have the option to regenerate all dirty operations. Post-selected operations runs the post processor and creates the NC program. High feed optimizes high feed rates for selected operations. This option is typically used in 3D machining where the programs are longer. Next, delete all operations, groups, and tools removes all toolpaths, tools, and machine groups from the Operations Manager. Below is Toggle. Toggle locking on selected operations locks and unlocks selected operations. Locking an operation prevents you from regenerating it. Toggle display on selected operations displays and hides selected operations in the graphics window. Toggle posted on selected operations enables and disables posting on selected operations. A Go symbol indicates that posting is off for the operations. Here we have the options to move the insert arrow up or down, after the selected group, or you can scroll to where the arrow is in the Operations Manager. Only Display the selected toolpath displays only toolpaths you have selected in the graphics window. Finally, Only Display Associated Geometry displays all geometry associated with the selected operations, provided that the geometry is not hidden or blanked and is on levels which are visible.